Hello everyone, welcome to another B.DevOps event. My name is Mihai and I am your host today. During the presentations, please keep your mics muted and use the chat pod for questions. I will make sure all the answers of the questions will be tackled at the end of each talk, and we will always have the buffer to go further with more questions and more engagements after the talks are done. I want to remind you that our events are recorded, and soon after we end the session, the recording will be published on YouTube along with the presentation slides, so you'll have the chance to get the slides as well. During the event, my colleagues will share a feedback form with you. Please take 2 minutes from your time and fill it out. It will help us improve the overall event presentation and will also give us some good ideas about what you would like to see on our next sessions. That being said, let's welcome Roman, our first speaker today.
Hi, so I'll share my screen now, start the presentation.
Hey Roman, yes, you can.
Can you see my screen?
Seems about right.
All right. So, I guess I can start, or should we wait a couple of more minutes?
Whenever you want. I think we can start with the first talk.
Yeah, so I'll start then. So I'm Roman from Booking.com. I'm from our team time series. We manage the ingestion, storage, and reading and presentation of the metric data. And my talk will be about Nanotube. It's one of our recent projects. It's a high-performance router for Graphite, and not only Graphite now, metrics. I'll start. I'll start from generic design, and I would like to mention that please ask questions and don't hesitate to interrupt, and then I will answer them right away so that we have a more live discussion. So starting from the generic picture, overall bird's eye view, this is how our system looks like. This is the full system end-to-end that we have for getting the metric data from our customers. It goes along the arrows, then storing it, and then serving it to the customers again. So this first overview is very high level, so no specific components. It's an overview by roles. Just to add, arguably we can't know that, of course, but arguably we run maybe the biggest or one of the biggest Graphite setups in the world now. We get in tens of millions of data points per second. And all these data points, they come from the users and they start coming in here, and they come from submission relays. These relays run on nodes. These can be hardware nodes, so servers, can also be nodes as containers in Kubernetes or virtual machines. The submission relays, they run locally, and they perform the role of control, what gets in. So first level of control over the routing and per filtering. They also perform the load balancing to the next level of the router. Also guarantee resiliency, specifically how I will explain later when we get in more detail. So making sure that when these second level routers go down, that we switch to another one. Then there is a second level router for the data that gets in, and that performs the key functions of duplication of data, sharding, and these in turn also guarantee resiliency. So the store does not have sharding and duplication by itself. So the store is rather simple as a model. It performs the functions of storage, obviously, and it also performs aggregation. Duplication and sharding are performed by the router. Then the data that is in store is read by the data reader, so it retrieves raw data. Since the store is not aware of duplication, it performs the deduplication and also healing in case if some stores that are replicas of the same data miss some points. Then the data is forwarded to the front end, and this has high level functionality. So parses the queries, does the mathematics, generates images, and then goes to the user. So one can view this in Grafana or can query the front end getting the images or JSON. There are multiple possible formats. So more specifically, here is our old setup, and we use CRelay. Here's the URL that ran on the node as first level local router running locally on the nodes. Then we used it as well as the second level router. We use GoCarbon for storage. And then to read the data, as the reader, we use Zipper. And for high level operation, we use Carbon API. Both of these are parts of the same repository, same project, actually. So Carbon API is mainly maintained by Booking, well, one of the forks. And the GoCarbon is not maintained by Booking mainly, but we have a very nice collaboration with the main maintainers. So the main action is going to happen around the relays, and they are in red. And these are the parts that are going to change. So what we changed during our progress forward and when we developed the Nanotube, what changed is that these two things were replaced with the Nanotube. This is the project like the talk is about. So that one is in Go and it's Booking owned, unlike the previous one. So now I would like to get into slightly more detail about how the write part of this pipeline works. So this means that we will be talking about this part. So from retrieving data from the user to writing it to the storage. So this is the write pipeline in detail. And it consists from the submission relay and the relay, which is the router, second level router, you could say. And this is the storage. So the data, we get the data in several formats. We get TCP and UDP via the line protocol. Line protocol is one of the most popular Graphite protocols to get data in. And we also now support OpenTelemetry with gRPC. But that support is in alpha, but we are moving in that direction. The line protocol is quite simple. It just consists of 3 values, which is the path to the metric, the value, and the timestamp in the Unix format. And then this data gets to the submission relay, which is this case is sub Nanotube, sub NT for short. It runs on a node locally. Then it forwards these records, this data, to Nanotube, which is the main router of the data. It has its own load balancing that has a health check. So it does not rely on any kind of distributed load balancing that would impose dependence on other systems, like some systems that are dependent on distributed consensus or anything. This makes it more reliable, because the less dependency we have on other systems, the better we perform in case of outages. And the whole point of this observability system is to give visibility, and especially visibility is important in case we have outages. So the sub-nanotube and the nanotube talk with the TCP or OpenTelemetry gRPC. Mainly we use TCP now. And then nanotube performs the hashing and replication to stores. Stores are organized by shards. And we write 3 replicas for each data point to 3 different stores. Stores by themselves, they are quite simple. They get the data and they store it. They don't do any kind of replication, sharding by themselves. This work is done by Nanotube. Nanotube also routes data to appropriate storages. Our topology of storages can be quite involved. So different data gets to different storages, and inside these clusters of storages, they get to different shards. Yeah, so this is how it looks in full detail. So this shows the full life cycle of metrics. So in the center, there are stores that keep the data. Then to the left side is the write pipeline that we just discussed in the detail. And to the right side is the read pipeline that I will briefly mention. So as just described, so there are submission nanotubes or submission relays that then route data to nanotubes. And each of these has its own pool of nanotubes and does the load balancing. So it's a hash load balancing. We send 1 copy and it has failover. So it's able to detect when a nanotube goes down. We also submit data locally inside one data center. And this ensures resiliency in case there is network cuts across data centers. Then Nanotube writes 3 copies of the data. And that is the duplication part. And also it makes sure that the data is stored where it's supposed to be stored. So in case we have complex topology of storage clusters, one data gets to one clusters, other data gets in other clusters. It also provides isolation. So it can happen that the storages are overloaded. So by keeping different data in different storages, we make sure if something happens, then the data can be read and there is no data loss. So that's also in security, in terms of data security thing, making sure there is no data loss. Also, one more thing that is interesting is that there can be multiple clusters of nanotubes. And the main reason for that is that we may want to have different routing for different submission nanotubes. So this means that some clients may want to have one kind of routing and some clients want to have another kind of routing. And the problem is that the data that is part of the line protocol does not contain any information about who is the producer of data. And so the main way to achieve that is to use different nanotube clusters for routing. So you can get different routing if you want. This part is the read. So C are the clients. Client sends a request, gets it to a load balancer, and the load balancer gets to front end. And then the front end does a smart broadcast. Sometime before, we just broadcasted to all stores. Now we try to be smart and only query the stores that are that have good probability of having the metric, but in the most simple case, we can query all the stores there are, then the data comes back and it's merged and then served to the user. And so the question is, of course, why would we do this? Why would we do all this work and do the replacement with the relay we had with Nanotube? And there are multiple reasons. So the first one is resiliency. The previous relay had a problem that there was correlation between the targets of relay. This means that if one of the target storages would fail or blip, sometimes that would cause other targets to be affected as well. And since the router performs the functionality of data duplication, in order for the replicas to be real replicas, they have to be independent. So this can lead to real data loss because it undermines data duplication. And yes, so this caused some real outages and data loss in our experience before. Another problem is observability. In the C-relay, there is little metrics, and they are routed together with this stream of metrics it actually routes. So there is internal dependency. This means that when it breaks, it may become invisible. So it's very hard to debug. Another thing is maintainability. So we strive for a simple design. Carbon C-relay is a complex project that grew over time to take into account the needs of multiple users, so it became harder to maintain. For us also was very important point that we have a good, reliable test coverage. We have unit test coverage that includes some simple end-to-end tests. We have fuzzing. We also have a full test suite that one can run to replicate like a real production system. So we have a synthetic sender and a set of synthetic listeners. They put Nanotube in like a real setup with data being sent to it that looks almost the same as a real scenario in production, but is run locally. So one can use that to have correctness checking and also to check the performance. Yeah, another problem was that we were unable to upgrade to newer versions because the C-relay did not work on our scale. We had it fail. We tried this a couple of times, and it would be unstable every time. So we just stick with an older versions. Another one is the configs were in its own programming language, and they were slightly harder to work with. And the project is in C. It so happens that our team has a lot of experience in Go, so that's why we moved to Go. Another thing is performance. So it's better. So the question is, of course, the obvious question is, how is it better if you move from the lower level language to the higher level language? I'll talk about this slightly more in next slides. Yeah, we also have the ownership of the project, so we can control that it actually satisfies the needs that we have and does not become too complex or be focused on users that are, for example, they work on much smaller scale, because it can happen with some projects that we in Booking cannot use them because on our scale the project is not performant enough or is not stable enough, but at the same time at the smaller scales it's fine. So we make sure that that doesn't happen with the ownership. And yeah, as I already mentioned, simplicity and simpler configs. So giving a little bit more detail to the question of performance, this is how it looks like when we moved from the C relay to Nanotube on one of our production clusters. So this is the CPU load over time. And we got the CPU drop of roughly 3 times. Since the CPU load is much smaller, we actually need much less boxes. So after this migration, because of better performance, we were able to clear like around 100 relay boxes and save some money. And Nanotube now, it can sustain around 400K records in, and if one sends 3 replicas out, this is around 1.2 million records out per second on a general compute with our production config. So these terms are fairly fuzzy. General compute is fairly fat server, and production config is quite a complex one. Our production configs are quite involved. On the simpler configs that have, say, around 10 routing rules or less, it can perform much better than this. So it can get 1 million records in fairly easily. So yeah, the question is why we were able to achieve performance. First reason, I think, is simplicity. I'll demonstrate this a little bit later. Second is that the design of the system was focused on performance from the get-go, and also the design of the system was focused on efficient concurrency. To illustrate the simplicity, I'll just have a side-by-side comparison of configs. So the C-relay config has its own programming language, which is a great fit when one needs to do something Turing complete and really complicated and perform some operations that are really involved. So it has custom validation of records, say it can have branching. And it has also the downstream stats, as I mentioned before. And the execution of this is imperative. And the thing is Turing complete. I don't know, but I guess it may be possible to write Tetris on it. I don't know that, but I guess it's quite possible that it is possible. It's a parsed data structure. It means with high simplicity, with high flexibility, it needs quite complex data structure to operate. And this, to put it very roughly, the data structure is executed every time it routes a record. So the routing is quite complex, and the data structure does not reflect how the routing actually happens. On the right side is Nanotube config. We strive to make it declarative and as simple as possible. It consists of 2 parts. The cluster's definition, which is the name, a couple of types of the clusters. Jump is jump hash cluster, broadcast, and load balancing. Yeah, the cluster has hosts. And second part is routing rules. The routing rule consists of the prefix and the regular expression, and then the clusters, which means if the prefix matches or the regular expression matches, then send to these clusters. Like to be completely open, we had for some backwards compatibility keep some imperative parts, but we strive to get rid of them, and we hope that in the future the config will be fully limited to declarative form. And having a declarative config makes it much harder to make mistakes, and also so the reliability goes up, and also it's much easier to work with. It's also much easier to work with because it's TOML. So it's easy to parse, easy to validate, comfortable to work with. So this is an illustration of the simplification that we did. And this is the main reason that the performance is better. Because in our case, we can achieve our needs with having this kind of routing. And this routing has a fixed data structure, and it is reflected by the architecture of Nanotube. Since it's so predictable and it's always the same, we can build the architecture to perform very well for this particular routing. So we can get better performance, even with a higher level language. And this is the architecture of Nanotube, the overall design. So when building it, the focus, as I already mentioned, was to make it simple and to have good concurrency. Fortunately, in Go, it's not so hard to get good concurrency. This is one of the reasons we chose Go. And this is how it goes. So we have a listener that gets the connections in. So these are TCP or UDP, or it's OpenTelemetry gRPC. It transfers the data that it reads to the main queue. The queuing gives the resiliency to load. If there are short spikes, you will fill up. It has a limited capacity. If the spikes are too much, there will be some data drops, but it will be resilient. It will continue to operate even if overloaded. Yeah, and resiliency is also one of the things that we were trying to get here, together with simplicity and concurrent performance design. Because as I mentioned before, one of the main reasons we started this whole project was that we did not have enough resiliency for the carbon C relay. So resiliency is also quite important. Then there are router workers that are concurrent. It's a very typical Go pattern that perform the CPU-intensive work of routing, matching. And then after the routing, they know which targets or which hosts the data have to go to, and they send it to these hosts. Hosts are organized into clusters, as you can see here. And each host has a separate queue. Having separate queues for each host ensures they are independent, and this solves the problem of correlation between targets that we had in Carbon C relay. So even if one host goes down, it will only impact the queue and the subsequent sender. The sender performs the work of actually sending out, so reconnections, making sure data is there, noticing when the data is not there or the host is down. This ensures its resilience, and it ensures that one host failure does not impact other hosts. And these are connections out. These are mainly TCP now. And one other thing is that we put in design was that it has a unidirectional flow and there are no loops. So there is very little to none interdependency and feedback, like backwards feedbacks in the system. This makes it much more reliable. It also allows for a graceful shutdown, because one can shut down starting from left to right the components and don't lose data during shutdown. It also makes sure that if things fail on the right, things that are on the left do not fail. And in general, it makes a system much more resilient, just because it's much simpler. And it's also simpler to reason about, so it's much harder to introduce bugs. Yeah, finishing up, I will talk about the next steps that we have in mind with Nanotube. We mainly use Nanotube right now to route the metrics that come from hardware boxes. There is a problem with Graphite when sending metrics from Kubernetes to Graphite is that Kubernetes tends to create very, very many metrics because there is a lot of rotation of pods. So if the metrics are pod specific, for example, include pod IDs, and there can be a lot of thrashing, and the number of metrics can grow very, very fast. And it's hard to ingest and take under control the metrics from Kubernetes. And this is, the next steps are in the form of a dependency graph. So to have metrics from Kubernetes, we need blast control. For that, we need usage stats. And in order to get that, we need to mark which data comes from whom. And to do that, we need data tagging, and data tagging comes with higher level protocol. And for this, we picked OpenTelemetry in a kind of special Graphite compatible format for now, but we hope to move on with it and make it more universal. This is the first problem that we are looking forward to tackle. Next one is metadata. One of the problems with Graphite is that it does not contain a lot of information that people would really like to see. One of the things I already mentioned, like the ownership. Another thing is type of the metric, and also like other types of metadata. For example, some kind of tags. And again, there is a problem that we need to transfer this metadata, and for that we need a higher level protocol. And next thing, we are trying to simplify the overall topology. I mentioned before that one has to run multiple clusters of Nanotube to have different routing. And then different clusters can be used to have different routing. And to get rid of these complex topologies, and get rid of the multiple clusters, we need to have the tracking of the origin, and we also need to route by the origin. And that also requires this information to be there in the metric. And this also leads us to the OpenTelemetry and higher level protocol. And we are also looking at improving performance. Getting better performance allows us to save costs by having less instances. And we hope to spend more time improving the performance of Nanotube even more. And merging the clusters by having routing by origin also allows to use hardware much more efficiently, because it can happen that one has small clusters that are underloaded. And this also allows to save money just on hardware. But another thing is that if there is a lot of unification, if the system is much simpler and there is much less fragmentation, then the system is much easier to maintain. So this saves time and money as well. And there is much less operations. So these are the next steps: support for Kubernetes metrics, metadata, simplification of the topology, improvement of performance, and with the hardware saving plans. Yeah, that's it. Thanks. We welcome contributions to the project. So here's the link. Here's the QR code with the same link. And I'm happy to hear the questions.
Thank you, Roman, for the presentation. We have 3 questions, and I'm still waiting for more from the audience, so guys, don't be shy. There was one from Alexander. He said something about, does submission relay acts like Carbon relay? But I think during the presentation, he found the answer. And there are 2 questions from my side. One is related to the size of the box. You mentioned on the performance related slide that your team managed to reduce 100 boxes And can you give the audience more details about what does it mean compute power for Nanotube? What was the pre-allocation and what is the current allocation? And like generally, what does it need for Nanotube to be able to process 1 million requests or metrics a second, as you mentioned before?
So we run on different boxes, but when I'm talking here about I think it's somewhere here. I'm talking about general compute. Then we are talking about CPUs that are Xeon CPUs and are either 24 or 32 cores. So this is server grade, really expensive fat CPUs. And the initial allocation was more than 200 boxes. And so we saved around 100. So we reduced the fleet not in half, but something in between 1/3 and half, think like this.
Okay, thank you. And my second question was related to the main queue, the processing queue on the design slide. What will happen in case of a power failure with the data already in the main queue?
So in case that the box just shuts down, the main queue is in RAM, so that data will be lost. There is a design blueprint, and it's visible. So if one looks up like the GitHub history, to preserve the data and reduce data loss by pushing the records that are the records that would overflow from main queue to disk. But that is for the future. Right now, but it's also slightly different. So when we are talking about the data that is in main queue right now, then if the shutdown happens, then the data will be lost. But the good thing I can say is that we did not see a good reason to tackle this problem. I'll explain why. So we are monitoring the main queue size, and usually the main queue size is close to 1. So the maximum size of main queue is millions of records, but during normal operation, when there is no overload, the main queue size is 1 or 0. So the queue is being emptied faster than it's being filled, which is, I guess, normal. Otherwise, that would not be sustainable. It only rarely happens that the main queue fills up. So the chances that the power failure of the box and the instant shutdown of the operating system would lead to some data loss are actually pretty rare, because the peaks, overload peaks, are rare. So it's not a problem. So we are not focused on solving it right now, but we are aware of it, and we also thought about it too.
Thank you, Roman. So as far as I understand, the data processing in the main queue, it's FIFO.
Yes.
Or you send batches out. You ingest probably from many more streams, and you send batches, or is like first in first out goes to the route no matter what?
It's FIFO and it's not in batches. This is what I mean when there is on average 0 or 1 points in the queue. This means literal Graphite data points. So 1 point on one graph at one point in time. And the main queue is actually a Go channel. So it's very well optimized for concurrency. And as a Go channel, it's a FIFO, yes.
Thank you. Nice. So, do we have any other questions for Roman? I don't see anything else on the chat pod. And I think this is it. Let's have a 2-3 minutes break and let's come back for the second talk. Do we have Norbert with us?
Yes, I'm here. Hello, everyone.
Hey, Norbert.
Hi, how are you?
Good, good. Nice to have you here.
Thank you for having me.
2 more minutes for you to prepare your deck, and yeah, let me know when you're ready.
Sure.
You can just share screen, and we'll follow you.
Absolutely. I think we have a couple people still waiting to join us all on our side, but whenever you think you're ready to go ahead, we can go ahead.
Up to you guys. Honestly, we have this break in between the sessions, but we don't really use it much. So the break is like good enough time to grab another beer or another glass of wine and continue the session.
Well, that's fair enough. I think let's give it maybe 2 more minutes to get to 10:02, and then we can kick off.
Great. Oh, kiddo.
How long is
Go on, sorry.
I was just curious, how long is the session? Is this the event usually lasts for the whole day?
So usually we plan it for 45 minutes. All the time we have 45-minute sessions. That mainly means 30 minutes the discussion, the talk, and then demo plus Q&A. But sometimes we go over time, sometimes we finish faster. It depends. It depends on the topic, on how much the presenter wants to share and go through.
No, that's absolutely fine. I think that's plenty of time for us to.
It's super flexible. This is a community event, and it's all about engineers talking to engineers and having some fun, learning new stuff.
Darren, are you on a call? Not sure if I can see.
Yeah, I'm here.
Okay. Just checking that our engineer is on the call as well. Okay, well, should we kick off in that case? Let me start sharing the screen.
Do you need a magic plugin installed, right?
I'm not too sure. I've given access just a second ago and restarted my computer, but it looks like it's asking me to quit and reopen. So I'll just be with you in 1 second.
No worries.
I might have to check mine as well then.
Hey, Emily.
Hiya, sorry, I was just on mute. Hi, how you doing?
Good, good. How's the weather on your side?
Cold, and we've finally allowed to go to restaurants and bars here in the UK, but we're only allowed to be outside.
Lucky you.
About 5 degrees in the UK at the moment. It's not as fun as it sounds. But we're powering through with lots of coats and hats and scarves.
Oh my God. At least you have the restaurants. I mean, there is an option there.
Exactly.
Can I check you can see my screen, by the way, guys?
Yes.
Yes, we do.
Cool.
Darren, do you mind popping on the presentation? If not, I have it in front of me.
Do you mind if you can share yours?
Yeah. I'm just trying to figure out. It's the first time I actually used the application itself. So, oh, there we go.
This is it.
No, I'm not too sure. Can you see multiple screens, or can you see my screen now?
Just
Actually, I
your
see your
one screen.
presentation. Your
Excellent.
one screen, if you click present, it should work. Or you present first, and then when you share in BlueJeans, you choose the presentation.
Apologies for this.
So we can't see it now, Norbert. You've just taken it off the screen. Here you go.
Do it again. Is it working now? Will it come off?
No, that's your inbox.
I'm clicking the right thing. Let me.
So I can see the slides now, Norbert. I think you just need to put it in present mode.
Yeah, I think it does have a delay because I'm not actually sharing anymore on my side. So let me just do it one more time and just be patient. See if it actually works. Any luck now? Do we have the?
Yeah.
Yeah.
Excellent. Well, thank you again for inviting us. Hopefully we'll be staying within time. The format from our side, I will take you through a very short introduction to the company, and then I will let Darren to actually give you the demo. Please feel free to ask questions as we go along and interrupt at any point. But we'll also hopefully leave some time at the end for any additional questions that are raised either in a chat or as part of anything else separately. So just very, very briefly, Kai, our CEO, he spent about 15 years working at NASA, European Space Agency, as well as working on some large transformation projects and change events. And in 2015, as he's working at the EE merger, him and Marcus came up with the idea and realized that there is a need for a new model of working, or for a tooling that encompasses the automation tools that are already in place, but also some of the human actions that interact with those tools. And that's how sort of the idea of Cutover was born in 2015. And on the back of that, Kai entered some of the innovation labs in New York and in London, and that's when we started working with one of our first clients at Barclays and JPMC. Since then, we've actually tripled, I think, last year in numbers in terms of employees. We went from one squad of engineers to 4 squads last year, so quite a rapid growth. Currently, we have just over 100 people, and we are, very, very fortunate to be trusted by some quite large companies and partners such as AWS and Barclays, Deloitte, Schroders, Nationwide, etc. So that's that. In terms of the actual use cases that we cover, we have 3 major use cases. Although there is a number of sub use cases that maybe are not so prevalent, but the 3 major use cases are technology, delivery and release, and things like change planning, optimization, change execution, etc. An example for release, for instance, is one of our customers, Nationwide, who they process a large number of transactions through their 24/7 online and digital channels. And making changes to the systems was quite a risky process for them, and particularly for any potential outages. Typically for them, any sort of major releases would require about 10 walkthroughs prior to using Cutover, and they were using quite incumbent tools that you probably see most of our customers is a combination of Excel and spreadsheets and sort of emails and calls to drive these releases. So really what the capacity for release has increased once they started using Cutover, as well as they were able to reduce the release failures. So simple things like building a release plan would normally take them a few days before using Cutover. Once they started using Cutover, they were able to template all the release plans they had, and within a matter of hours, they were ready to kickstart another release. as well as the 10 previous walkthroughs they had to go through to be able to release any changes for the platforms. Now it's actually all consolidated into one dry run. So that's again enabled them capacity to do more releases. From an operational resilience standpoint, what Cutover is used for today is things like resilience testing and building power downs, failover testing. For instance, Barclays keeps all their 5,000 service recovery plans in Cutover, ready to be actioned whenever needed. They moved from the proprietary tool and migrated all to Cutover, and they run their data center recovery tests and mainframe tests and etc. all through Cutover. From a transformation perspective, it's a bit more wide. We do have and see a number of different use cases, things like data center migrations to the cloud, SAP migrations that Cutover is being used for, or even things like HR systems that would migrate to, like a Workday migration from some of our clients. An example for transformation is, for instance, JPMC uses us for a data center migration project they're currently running. And the scope of the project is really to move from, I believe it was 14 data centers down to 4. And they had to migrate approximately 2,400 applications. So as a consequence, because of a quite tight schedule, which they have 3 years to finish it, their normal volume of change has almost tripled. So before using Cutover, they really needed some tooling to be able to sort of cope with that and make sure that they mitigate as much risk as possible. And one of some of the features that they looked at again is the ability to templatize things and runbooks as much as possible. And also the ability to execute automation through Cutover, so things like integrating with their other tools that they're currently using, as well as manage to execute the execution piece, but also the planning piece to make it a lot more faster and robust to cope with the amount of change they have to do. And then thirdly, but not lastly, in terms of where we fit in the sort of tech stack, the one word we tend to use is we see ourselves as a orchestrator of orchestrators. So what does that mean? That we sort of sit at a sort of as an agility layer in between your existing automation tools. And we do have capabilities to integrate with a number of these tools. And it's something that we're continuously developing with our customers and clients. This is it for me from the presentation standpoint. I didn't want to take too much time. I'll let Diren to give you a demo of what we just talked about. I believe the demo will be focused more around release, but please do ask questions and feel free to interrupt us.
Perfect, thanks, Norbert. While we switch over screens, is there any questions from the audience, or should I crack on and start sharing my screen?
Well, we don't have anything on the chat pod yet, so I think we can continue with the demo, and probably during the demo we'll get some.
Okay, perfect. Cool. So just checking, you can see my screen. It should have a number of different colors and things on a calendar view. Hopefully, I'm showing the correct screen here.
I initially thought that was your calendar.
Yeah,
but yeah, it's colorful.
Perfect. Cool. So let's get cracking. So as Norbert quite rightly said, I'll give you a quick overview of the tool. Now, we will focus more on sort of release management, but hopefully you can think about how Cutover can be used in other areas like operational resilience and transformation, and even maybe other use cases where you might need a runbook to orchestrate some activities. But what I wanted to start off with, for starters, is this events view, this calendar view that you can see. And as you quite rightly said, it looks very, very busy. So this is essentially to show you what we can do in Cutover, and just to give you a real life example, one of our clients is currently using Cutover to essentially schedule their portfolio of change. So within their global payments, they do hundreds of changes every day and every week. And therefore, they need a way of being able to schedule and visualize all of these changes. And previously, they were doing this on Microsoft Excel on spreadsheets. And you can imagine, having hundreds of changes in a list view in a spreadsheet isn't really ideal, and you can't sort of visualize when things are happening and conflicts and clashes and so forth. So they started using Cutover to schedule this. So what this gives you is a calendar view of all your changes, and they've got a 12 to 18 month view of change, and here we've simulated that sort of view of change that they have. So if I just zoom out, you'll be able to see we've got events going on across the year. But what we also have the ability to do is then slice and dice this view to particular views that you might be interested as a user to see. So not only can you see all the events here, and you probably notice these lines here, these are showing dependencies between events, but you can drill down to certain views, you can group by, or you can spotlight attributes. So let's go ahead and actually sort of drill down and slice and dice these views to something that's more manageable. So on the left-hand side, we have this notion of folders, and the folders can be, anything that you want to use to group your events by. It could be lines of business, it could be projects, it could be technology divisions, or whatever it is. We've gone with, sort of lines of business, but we also have other metadata that we've tagged our events with, so such as application affected, what the risk rating is, what location it's being executed in, and this can be whatever you want, and it could be fed from your CMDB or your ITSM tools as well. So if we want to, let's say group by lines of business, we can click the group by attribute, and it will essentially group all of those events together into their different respective groupings. And now what it's showing you, it's collated all of those events, but it's now showing you the volume of activity happening across each of those lines of business, indicated by the blocks. I'm going to focus on digital here, but you can see, if I go across the screen here, we've got, 3 events on each of those respective days. And obviously, the larger the blocks, the more activity that's happening on that given day. So as a stakeholder, you might want to see, or you might want to focus your attention on those larger blocks, because that essentially means for digital alone, you've got more activity happening on that given day. And, to increase the success rate of your releases, your implementations, you might want to de-risk that change window or that day of change by rescheduling some of your changes. And being able to see that, the volume of activity early on is really key for Barclays. And a great example is, having to see or being able to see just before COVID happened, what events that they had, what releases they had scheduled, and what are the knock-on impacts if they had a change freeze and had to reschedule. Being able to see all of that in a calendar view in Cutover was really, really valuable. So here, what we can see, as I mentioned, we've got a larger block for digital. We can expand accordingly and see for that given day all of the events happening. And then I can reschedule those events to the left or to the right and immediately see what the knock-on impacts are. And if you remember in my previous view, I had lines between events. If I had lines between some of these events, if I was to move one to the right or to the left and it had successors or dependencies, you'll be able to see what the knock-on impacts are straight away. And then, over and above this, not only do we obviously show you this, but then you can spotlight attributes. So, we've grouped by a certain attribute, but then I might want to bring in, okay, what are all my risk ratings for each of these events? So here I've spotlighted all the risks, and it's now showing me all the different risks. And then furthermore, as a stakeholder, I might only be interested in the high risk items. So I want to drill down into those. I can then filter down into those and view all of those items. So it's just essentially being able to manage your views, and we're giving you the flexibility to do that. And as I mentioned, and I'll probably talk about Barclays a lot, But Barclays are using this to not only schedule their change, but they're using this to drive their change advisory boards as well. Every week or every 2 weeks, they meet up and view all the changes that are coming up in the next 2 weeks and the next month, and make those key strategic decisions that they need to, rather than getting to the day of the event and realizing they need to change or reschedule, which is obviously going to cost them money, but also time and resources. So it's giving you that early sight of change and conflict as well. So going to pause quickly there. Any questions? I'm not monitoring the chat, so if there is anything, please feel free to shout.
Nothing so far. I think we'll have some questions at the end, I guess.
Okay, perfect. All right, so I'll continue. So this is obviously a calendar view, events view, high level view. What we also have underpinning each of these lines, these events, you can attach runbooks against them. So not only can you see metadata, but you can see runbooks, and your runbooks are your list of tasks that you need to execute. And this is the other side of Cutover, so the automated runbook technology as well. So if I just go into a runbook, this is what a runbook would typically look like. You've got your list of tasks ordered by date, time, and duration order. You've got a number of different shapes and different colors as well. Now, if I just touch on the different shapes to start off with, in Cutover we have different task types, and they all behave slightly differently. Now, I won't go through all of them, but I'll touch on the main ones. So we've got your milestones, your checklists, your checkpoint tasks, where you want to indicate you've reached a key point in your runbook, and it's obviously good to have a number of milestones in your runbook to be able to monitor and track progress. And then we've got tasks that are what we call our normal task types, tasks that have durations. You can see here we've got a duration on the right hand side, and there's also other tasks in my runbook that have durations as well. What we also have is what we call a checklist task type. So rather than having a duration, you might want to put a due date as to when that task is due, a deadline. So it can take however long you want, but it just needs to be completed but by a certain date and time, and therefore you can add a deadline to that. Then what we also have is our communication task types. You probably notice a couple on my screen. These are the circle with the brackets, email and SMS, and we've also got another one which is a call task type. And these are where you can pre-plan your comms to your stakeholders, and with a click of a button, Cutover with either email, send a text message, or call those individuals and host that conference call for you. So remember, these are your planned or your pre-planned comms, and rather than having to go to your Outlook, etc., you can do it all via Cutover, and Cutover will email them. Now, obviously, we understand when you're in execution, you might not always plan when you want to send out your email or send out a text message. Something might arise, and you might want to initiate or broadcast some comms at that point in time. We also have the ability to do ad hoc comms at the top. So that is at any point in time in your execution of your runbook, you can send out an email, a text, or call individuals. Now, with all that being said, these are our default task types in Cutover. What we also have is the ability to integrate with other IT systems within our client's IT landscape. So we can integrate with collaboration tools like Microsoft Teams or Slack, DevOps tools, things like Jenkins, Ansible, Chef, Puppet, etc. And then I mentioned earlier on ITSM tools as well, ServiceNow's remedies, and their respective CMDBs as well to surface information or update change request information, or change requests and close change requests, tickets, etc. And then if we just touch on the different colors that you can see on the left-hand side, we have this notion of streams. A stream is essentially a logical grouping of tasks, and we've structured our streams here but by different phases in a release or a migration. It's really flexible in terms of how you want to structure your streams and therefore your runbooks. So completely up to you, and you can go down to a substream level if you want to. But you'll notice that each of these streams have got different colors associated to them, and that's what these different colors represent against the icons here. Now, if we go all the way to the right-hand side, not only do we have or we capture durations, but we also capture who's assigned to those tasks. And you can see if I hover above these letters here, we can see who's assigned to them. And in this case, we've assigned it to teams. And within those teams, you can have an individual or you can have a number of individuals. Alternatively, if you want to assign it to individuals directly, you can do that as well. Completely up to you how you want to do it. And then the final thing I just wanted to show before I put it into execution and show how you interact with the runbook is right now, all of these tasks look like they're happening in, a sequential order, one after the other. Now that's not the case. As with any good plan, you'll have dependencies that you've identified, and you do exactly the same in Cutover. But what we also have is what we call a node map diagram, which is a pictorial representation of the runbook. It shows you how your tasks are structured and all your interdependencies. And not only that, it will also show you or draw the critical path for you, which is the orange line going from top to bottom of the runbook. And these are the critical items. And just to reiterate that this is dynamic as well. So when you're in execution, if tasks that are currently not on the critical path are going to impact the end of the runbook, then they'll dynamically fall and the line will get redrawn to encompass them as well. Now, this is an interactive node map, so you can zoom in, zoom out. You can click on the individual nodes, view the details of the task. You can also edit in this view as well if you need to. So just going to quickly pause there. Any questions?
We have a question from Alexandro. He's asking, is the data pulled from a CMDB?
Are we talking about the data, the contents of the runbook, or are we talking about CR data or something like that? Because if we're talking about CR for the events, okay, yeah.
Yes.
So it can be, or it can be manually ingested. If, for example, when I spoke about Barclays, that they had spreadsheets and they only used to raise CRs 4 or 5 weeks before the change was going to take place. So we ingested all of their information from the spreadsheet into Cutover, so they've got that main view. And then, what we're working on with them right now is that integration with ServiceNow, which they use, or they call it Service First, where when a change is created or change ticket is created, you can link that event with that change ticket, and then associated information against that can be pulled into Cutover or surfaced into Cutover.
And we have another question still from Alexandru. So it's a business process manager for release management of new code.
I mean, that could be a potential use case, yes. But there's many different use cases for Cutover. But yeah, that could be one of them.
Thank you.
Okay. All right. So I'll continue. So right now we've been in what we call the planning stage. But let's go ahead and go and execute it. So imagine, we're in a scenario where we've got our runbook and we want to execute this change or this release or whatever we're doing. And orchestrate these activities between humans and technology. So I'll put this runbook into an execution mode. Now you'll see a couple of things when I put it into execution mode. So first thing, obviously at the top, the elapsed time is now started to count up. And apologies, I think it's because I'm sharing my screen. It's taken a bit longer to upload, but there we go. So you can see at the top we've got the elapsed time counting up. So that will continue to do so until you either pause or cancel the runbook. And then we've got a number of tasks here which are sort of grayed out, and that's basically Cutover's way of saying that these tasks are late according to the plans. Sorry, not late. These tasks are not yet startable according to the dependencies that you've mapped out in planning, and therefore the dependencies haven't been completed yet. And then we've got the first task here, which has got a little play icon in there. And that's basically Cutover's way of saying that this task is startable. So as soon as a task becomes startable, it will have a little play icon in the middle. And as well as that, it will also notify whoever's assigned to that task. So in this case, whoever's in the command and control team will get a notification to say that your task is startable. And that notification is via email and SMS. Now, when tasks are late, you probably won't see it on this runbook, but when tasks are late, they'll turn orange, and that's Cutover's way of saying that those tasks are late. And if you hover above them, you'll be able to see how late they are according to the planned start time, etc. So as I mentioned, if you're assigned to the task, you get notified that your task is ready to start. So imagine I've got the notification for this one. This is a go, no go checkpoint. So we're just going to go ahead and proceed with the runbook. But you'll notice as soon as I complete that task, it will then automatically send a notification out to an MS Teams channel that I've obviously predefined in my planning stages. So this is where we're just pushing a notification out. And then we come back into some manual tasks, again, notifying a human being or human beings that their tasks are ready to start. With a milestone, it's just one click to say that we've completed it. And then with a normal task or a task that has a duration, it requires 2 clicks this time. So 1 click to say you've started it, and obviously the best practice is to start it when you actually start the execution of that task. Go away, execute that task, and then another click to say that you've completed that task. Now, you'll notice a couple of things when I do complete the task. It will give you the actuals here on the right-hand side in terms of how long it actually took me to execute that task. But not only that, it will unlock the next task, but also reforecast the start time for those next tasks based on the dependency tree that you've identified. It will reforecast the start times to the current time. So rather than waiting 10 minutes to execute the next task, it will reforecast it to start as early as possible. So if you end up completing this task ahead of 10 minutes time, then you can start it as early as possible. You'll see if I hover above it as well, you see the elapsed time. So we've been, this task has been running for just under a minute. And what I'm going to do is go ahead and complete the task. And as I mentioned, we'll give you the actuals here on the right-hand side. We'll also work out the deltas. So how long did it actually take you versus the planned time? So we've saved here 9 minutes or just over 9 minutes because we executed our task in 58 seconds. Before I go over to the dashboard, I just wanted to quickly touch on the Jenkins one. So with the Jenkins one, obviously, as soon as the dependencies have been completed, it will then contact or connect with Jenkins and initiate the job that you've identified in planning. So in planning, you identify what job you want it to execute. In execution, it will initiate that job. It will connect to Jenkins. Once it's connected to Jenkins, found the job, it will execute that job, and it will monitor it via Cutover as well, so show you progress in Cutover. Now, because obviously for demo purposes, it's not actually connected to a Jenkins instance, what it is, but because I'm in a rehearsal mode, it's not actually going to execute the job. But in reality, what would happen is that it would execute it. It will show, progress in this task view, task line here, and then once it's completed, it will then complete the job or complete the task automatically, and then unlock the next tasks in the sequence. So as those automated jobs are being executed in the background, what I'm going to do is actually navigate to the dashboard. So not only can you see everything that's happening in this single view here, but we also have a real-time dashboard as well. So as things are progressing in your runbook, people are interacting with their tasks, automated jobs are being executed, etc. Your dashboard is updating in real time as well. So you can see here, our progress, we're going from 1% to 3% and 5%, etc. And you'll be able to get a real-time view of exactly what is happening. Stakeholders who have got an interest in your execution in your runbook can navigate to the dashboard at any point in time and view all of this information from a click of a button, rather than waiting for progress updates or the project manager to provide them with an update or a dashboard. This is all available readily at any point in time. And the best thing as well, because we're a SaaS platform, you can access Cutover via any device. It's not an app. You go via URL, you log in, and you can see all of this information on any device, whether it's your laptop, whether it's your phone or your tablet. Obviously, the screen will render according to the size of the device you're using. So that is essentially Cutover in a nutshell. This is a single dashboard or single runbook that we've been focused on, and a single dashboard. But what happens when you're executing multiple runbooks or multiple releases happening at the same time? What we also have is the ability to view that in a dashboard in what we call the multi-runbook dashboard view as well. So here we've got multiple runbooks being executed. You can see how far along they are. And we're just giving you that summary view for then you to drill in and find more detail. As a stakeholder, you might be really interested in saying, okay, there's 2 red items here. What are my 2 red items? You can click on those here. It will pull up the details on the right-hand side in terms of the runbooks. You can then drill into each of those runbooks individually and find out more details as to why it's red, what's causing it to be delayed. Is there a way that you can, pull it back onto a happy path or to the green path, etc. So we're trying to give you all of this information readily available for you to then make those key decisions that you need to. So I appreciate I've been talking for quite a while. I'm going to stop here now, open it up to any questions, and we'll go from there.
Thank you. Well, that's really interesting indeed. I have a question myself. I was actually looking forward to see the post-production application of Cutover. Like I'm imagining some scenario where you have PagerDuty in place. I'm just giving you an example, and based on a specific alert, you can trigger a Runbook or an automatic action in Cutover. Is that a possible scenario?
It is possible. What you'd probably have is a canned set of runbooks, templated runbooks, and then would have an integration with PagerDuty or any other tool. It might even be an ITSM tool where when an issue arises or crisis or some sort of alert, it will then trigger that runbook to be created based on a template, and then assigned a runbook administrator, etc. Then that person would then execute that runbook. So that is definitely possible. Unfortunately, I don't have that to show today, but it is something that is possible via Cutover.
Just a follow-up to my previous question, because at the beginning I've seen a map of integrations, and I see that Cutover can integrate with a few CI/CD tools. You specify Jenkins, Puppet, Chef, or Ansible, and that relates to my question. If a system has a failure, right, and I trigger based on that, I can trigger a runbook in Cutover to, I don't know, pre-provision something or execute some Ansible commands. Is this possible, right?
Correct. Yeah. Yes, that's right.
Okay.
So the example that you saw in this runbook, imagine something failed and you needed to execute a runbook, and this runbook was a list of, Ansible jobs or Jenkins jobs like this one. It would essentially, so for example, in this one here, you would identify what the job name is, and it will just trigger that off once you've triggered the runbook off.
I see. And you said Jenkins, but what about other tools? They require a specific plugin to talk to Cutover, or you can integrate almost everything that exposes an API.
Yeah, exactly. So we do most of our integrations via REST APIs. So providing it's got REST APIs, which most of these tools do, then we can integrate with them. So don't require a plugin or anything like that.
Oh, nice. We have a question on the chat. Vitali is asking, what about the forks in pipeline? An example being deployment of a new version was unsuccessful and it requires a rollback. How does this look in a calendar view?
Yeah, great question, and it's all based on how you structure your runbook. So you could have a decision point in your runbook, and that decision point could be, was it successful, yes or no? If it was yes, then you complete your runbook, you close your ticket. If it was no, then you go down your rollback steps that you've outlined in your runbook. So you have the ability to do that in Cutover. Unfortunately, again, I don't have the example here in front of us, but you could, if you just imagine a tree where you'd have go down one path if it's yes, and another path if it's no, then that's all possible in the tool. And it doesn't necessarily have to be 2 paths. It can be 3 or 4 or 5 different paths depending on what your decision tree is.
Well, I hope it answered the question. Currently, we don't have any other question in the chat.
Okay, perfect. Well, thanks for your time. I'll hand back to Norbert just to close up if there's any closing remarks.
Well, no, thank you for your time, Mihai, and thank you everyone else for inviting us over. Again, if you found the session interesting, if any questions crop up after we left, or there's any more things that you guys want to know about, feel free to either reach out to myself, Emily. If you want the presentation that I put forward in the beginning, it has an appendix with screenshots and a bit more information in terms of available integrations and some of the architecture pieces. Happy to send that over as well. I can send it to you and you can circulate it to everyone else. Maybe that's the easiest, but if there are, again, anything else, I'm happy to provide it for you.
Thank you. Yeah, that will definitely help. And yes, I encourage everyone to reach out online to the website, read more about the solution, maybe request a demo or play with a demo if there is any available already. And I think that's everything we have for today's event. Thanks everyone for joining. Thank you guys for joining and presenting your product. I just want to remind you to fill up the feedback form for us. It is going to help me and my team to improve the event and bring interesting topics that you would like to see. That's one. And second, immediately after the call, I will upload the recording on YouTube, and I will share the slides, all the slides with the participants. Thank you for joining. Have a sunny day or evening ahead, and I hope to see you next time.
Okay, thank you very much.
Thank you.
Bye, everyone.
Bye-bye.